4.3, derivatives of inverse trig functions. Now this gets real messy, but the one you really got to know from all this is arctan. And we'll do it all, and you got to memorize a bunch more crap. But yeah, if you know arctan, I think that'll get you through just about everything you need in the AP exam. Well, for my class, for me, you got to actually know what you're talking about. So let's see what we remember about these things. Arc sine, graphed. So sine does this. So arc sine does this. And its domain is -1 to 1. Its range is -pi/2 to pi/2. I feel like I'm making a mistake in including those. No, it goes all the way up to the end. -pi/2 to pi/2. Yeah. Arc cosine should go like that. That's tricky to reflect. So it does something like this, if I'm not mistaken. And its domain is -1 to 1. But its range is 0 to pi. And just to remind you, this is the one I really want you to pay close attention to because I've seen problems that require knowledge of this graph. Tangent does this, so when reflected, it does this. What am I talking about? Reflecting through the y equals x because it's an inverse function, blah, 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 blah. Domain is all reals. I want to write it. And the range is parentheses, -pi/2 to pi/2. It never actually gets there, an asymptote. All right, so remember these are inverse functions. So for something like tangent reflects through the y equals x line. I've used this to solve problems, so I'd stay on top of that if you can. So let's derive the derivative of arc sine. Shockingly enough, we need to do it implicitly. By the way, we're using arc sine instead of sine, taking -1 of x, because we have had problems with 1/sine of x, which would also be written as sine of x to the -1, and it causes problems. So we're going to avoid that. Now, y equals arc sine x. Now, I've spent a lot of time screaming at students in the past. I don't teach trig much anymore. Don't read that problem. Read x equals sine of y. So when someone says y equals arc sine, I say, where does sine of y equal x? I immediately turn it around. And it makes life a lot easier, especially in calculus, because now I can just use this cool new implicit tool I have. 1 equals cosine of y, and you say dy dx. You say, well, great, so dy dx equals 1/cosine of y. What if I don't know y? What if I don't know this? What if I don't know that? Yeah, we like to write our derivative rules in terms of x. So, let's see what's going on. I don't know what about you, but when I run into trouble in life, banker's not helping me, or fast food restaurant where my food's not coming fast enough, what I do is I draw a triangle. Solves all my problems in life. This says sine of y, sine of some angle y equals x, technically x over 1. Sine of y equals x over 1. Sine, if I'm not mistaken, and it's been a while, is opposite over hypotenuse. And I think that makes this square root of 1 minus x squared. And I'm doing a guess and check thing here, because if I square this, I get 1 minus x squared plus x squared. They cancel. I'm left with 1. Neat. So dy dx equals 1/cosine of y, adjacent, square root of 1 minus x squared. over 1. I'm not going to write it. By the way, x has to be less, absolute value of x has to be less than 1. Can't be bigger, can't take square root of negative, and it can't be 0. It can't be 1 because we'd have to take the 0 on the bottom. We'd be out of luck. You don't have to worry about that. You do need this. I have seen it. It is on my test, and I have seen it on an AP test, although it's rare. There is so very much material to test you on that they will often just say, let's keep it straightforward and just give them arctangent. You'll see why when we get to arctangent. It's a lot simpler looking formula. Also, there's that whole domain and range thing. I think that has something to do with the whole -1 to 1, but here it's included and here it's not. Yeah, don't worry about it. So, just said I wouldn't do this and I did it. You'll notice I do that often. ddx of arc sine of x squared equals 1 over, now careful here, square root of 1 minus whatever's inside here squared, x to the 4th, chain rule times 2x. Oh God, there's going to be all sorts of simplifying and multiplying by, no, there's not. By the way, that means I drew a 2 and then I changed it to a 4. That's it, done. This is why at the beginning of this chapter, we have Yoda saying, do or do not. There is no try. It's doable. Just follow the steps. Don't forget the chain rule. There's no big secrets in there. How about tangent? And then how about secant? Hey, what the heck happened to cosine? Trust me, you know what happens to cosine. It's a c, therefore, it's just a negative. Y equals arc tangent of x. Tangent of y equals x. You know what? I'm going to need a triangle eventually. Might as well get on that. Y tangent x over 1, opposite x over 1, meaning this is, turn the page just for a moment. Square root of 1 plus x squared. Why don't we write it as x squared plus 1? Just deal with it. Sheesh, bunch of whiners. All right. Secant squared y dy dx equals 1. Dy dx equals 1 over secant squared y, also known as cosine squared y. Nice. It's got a y in it. Sons of guns. Dy dx equals cosine adjacent over, what's with the parentheses? You'll see 1 plus x squared. Squared equals 1 over 1 plus x squared. I have seen it written as x squared plus 1, but that's usually the way they write it for reasons that don't make any sense to me. There's arctangent. A lot easier than this one. No square roots. But, yeah. All right, arcsecant. Y equals arcsecant. By the way, I don't have any of these memorized. I do have this one memorized, but I just rederive them as necessary. Secant of y equals x triangle y. That's 1 over cosine of y. Now I'm confused. Well, wait, no, I know what to do. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. X over 1. And again, I'm just going to guess. Square that, I get x squared minus 1 plus 1. And then we take square root, I get x. Nope, lost me. 1 squared plus square root of x squared. Oops. Minus 1 squared equals x squared. Not that squared. Now let's see what happens. 1 plus x squared minus 1 equals x squared. All right. I guess we got lucky. All right, so secant of y. Oh, I haven't done any calculus. So that's secant y tangent y equals 1. dy dx. Let's make this a little simpler. Dy dx equals secant 1 over cosine. So I can just slap a cosine of y up here. Then the tangent y comes down when I throw it on the other side. Cosine of y, 1 over x, tangent of y, never seen this on the AP exam, but it will be on my exams. Now they've got this weird thing in here where they say, well, that can't be negative, and because then, whatever. So they slap some absolute value on there. Why, I have no idea. I mean, I've looked it up and I've been able to explain it, make sense of it, but nope, doesn't make any sense to me. So there they are, arc sine, arc tan, and arc. So well, what happened to the, just slap negatives on them all for the other ones. That's it. See, it's got negative. All right. Look at me breaking the rules again. X of t equals arc tangent t to the 1/2. What's the velocity when t equals 16? X prime of t equals 1 over 1 plus that squared t times the derivative of that 1 over 2 root t. X prime of 16 equals 1 over 1 plus 16 times 1 over 2 times square root of 16 equals, go left, turn right, upside down, 8 times 17. Am I really supposed to know that off the top of my head? 1 over 136. No units. Always remembering to check for units. I'm pretty proud of that. Make me rewrite it again. Arc secant 5x to the 4th equals 1 over whatever is in there. Square this, 25x to the 8th minus 1 times 20x to the 3rd by equals 4 over, that was x to the 4th at one point, so it's going to be positive. So I don't really need the absolute value, but you know what? Let's just leave them in there because we're that weird. 25x to the 8th minus 1. So it's just plug and chug. You just follow along. There's no, again, back to Yoda, do or do not. It is not, well, you got some problem solving ahead of you. You're going to have to really think about this and try it. No, we just, derivatives, just go. An equation line, tangent of the graph of y equals, well, we didn't do arc cotangent. Yeah, it's just negative. So equals arc cotangent x. Nice. Wait a minute, find equation line tangent. That means I need the points. I don't know what to do with that. I do know that cotangent of y equals x. So where does cotangent of y equal -1? Tangent's first and fourth quadrant. I bet this is at -π/4. No, they're saying 3π/4. That's very upsetting. Very upsetting. Y equals 3π/4. I know 3π/4 works, but I figured cotangent and tangent have the same domain. They don't. Upsetting. Well, go look it up if you're confused. So the point is -1 comma 3π/4. And the calculus is dy dx equals to negative over 1 plus x squared. Dy dx x equals -1 equals -1 over 1 plus 1 equals -1/2. So tangent line y minus 3π/4 plus 3π/4 equals -1/2 x plus 1. Cool. By the way, notice there's no button for these on your calculator. So since secant is the inverse of cosine, they've got all this fancy stuff. No, I would never do this. Secant is cosine the negative first. Inverse, we got to flip it, 1 over x. What? Yeah, trust me, it works. And cosecant negative first would be sine to the negative first, 1 over x. Yeah, you know what? I wouldn't worry my little head about that. Yeah. So you'll never have to put these in. But if you did, you've got them on this page. How would you graph them? Oh, they're on the page for you. Just keep you on your toes. Hey, what a nice guy. I wrote all these out for you with the absolute values and a U, so you'd hopefully remember the chain rule, although I doubt it. Good luck and happy mathing.